Good morning all. Today in this session, let us continue to discuss Fourier series expansion in the interval 0 to 2L. So in the previous three sessions, we had seen minus pi to pi, minus L to L, 0 to 2 pi. And further, in this session, we will be studying about Fourier series expansion of f of x in the interval 0 to 2L. So straight away, let us get into the problem, as the formulas and all, the procedure and all is the same as we have already discussed in the three cases. So if you look at the first example, obtain the Fourier series of f of x, which is given as 2x minus x square in the interval 0, 2. So whatever the interval has been given, it must be compared with 0 to 2L. So interval must be compared always with this, whatever the number is given here is 2L. So here the interval is 0 to 2 and the standard interval is 0 to 2L. So when I compare these two, we come to know that L is equal to 1. 2L is equal to 2 and L is equal to 1. So here f of, now we need to check the function is whether even or odd. Wherever it is possible, if we can able to conclude the function is even or odd, it is very helpful for us in reducing the length of the problem. So that is the reason first we will check that. So f of 2L minus x, as we discussed in interval 0 to 2 pi, even for 0 to 2L the same procedure we will apply. So replace x by 2L minus x. So on the other side we will get f of 2 minus x. So which is equal to 2 times of 2 minus x the whole square minus 2 minus x the whole square. We have just replaced x by 2 minus x. So 2L minus x, L is equal to 1. So 2 minus x is going to be replaced by 2 minus x. So this is what expansion we had got it. 2 minus x whole square is a common term. You can take it out. Remaining is 2 into 2 minus x has been taken out, and 2 into 2 minus x is there. And further simplifying, we had got 2x minus x square is equal to f of x. It is same as our f of x. So we had replaced x by 2L minus x, and finally we have arrived at f of x itself. That is the given function. So this shows that the function f of x is equal to 2x minus x square is an even function, and once it is even, bn will be equal to 0. So now we need to evaluate only a0 and an. So the formula for a0 is, actually the formula is 1 by L integral 0 to 2L f of x dx. Since f of x is an even function, integral 0 to 2L can be written as 2 times of integral 0 to L. So that is what we had obtained here, the formula. The formula here is 0, this is what the formula. And now let us substitute for L, 2 by 1 integral 0 to 1, 2 minus x whole square into dx. So let us integrate now. Integration of 2x is 2x square by 2, and integration of x square is x cube by 3. And substitute the limits between 0 and 1. So 2 times of 1 minus 1 by 3 minus 0, that is equal to 4 by 3. And now let us consider the formula for an. An is again 1 by L integral 0 to 2L. Since f of x is even, cos is also even, product of even function is even, integral 0 to 2L can be written as 2 times of integral 0 to L. So that is why we had gotten formula for an as 2 by L integral 0 to L f of x cos n pi x by L into dx. So substitute for f of x, 2x minus x square into cos nx, and with the value of L is equal to 1. So now we need to perform the integration. Integration by parts or integration by Bernoulli's rule can be done. So here 2 outside, which is their as it is. First function as it is, integration of the second function, and differentiation of this is 2 minus 2x, and integration of this is minus cos nx by n square pi square. And again differentiation of this is minus 2, and integration of this is minus sin n pi x by n cube pi cube. And next term will become 0, so we will stop the procedure at this stage, and everything has been evaluated between 0 to 1 limit. Now substitute the upper limit minus the lower limit. So once we make a substitution for upper limit minus the lower limit, we get 0 everywhere, as x value is 0. And for the lower limit, we get only this term. And the final answer for an is minus 4 by n square pi square. So you have to work it out and check whether you get this answer. And now, since we have evaluated a0 and an values, we have to substitute it in the main Fourier series expansion. This is what is the Fourier series expansion. F of x is 2x minus x square, and a0 value is 4 by 3 and that, and an is this. So on simplifying, we get this expansion. So if it is only Fourier series expansion is asked us to obtain, we can stop the procedure at that stage itself. There was no proper deduction like only the answer should be in this form or show that the answer is this. There is nothing like that. So we can stop the solving the problem at that stage once we obtain the Fourier series expansion. So let us see another example. Obtain the Fourier series of f of x, 2 minus x and x minus 6. So interval is 0 to 8. Interval 0 to 8 has been split up into two parts. One is 0 to 4 and the other one is 4 to 8. So, and hence we need to get this particular answer. So here let us take the interval 0 to 8, and actually the standard limit is 0 to 2L. So when we compare 2L is equal to 8, we get the value of L is equal to 4. So the given function is of the form f of x is equal to phi 1 of x, phi 2 of x. Phi 1 of x is 2 minus x in the interval 0 to 4, and phi 2 of x is x minus 6 in the interval 4 to 8. So that is what has been given, and now let us check the even function, even and odd nature. Consider here phi 1 of x, that is 2 minus x, and x is going to be replaced by, let us replace x by 8 minus x, that is 2L minus x. So when we replace it, 2 minus of x is 8 minus x again. So when we simplify, we had got x minus 6. This x minus 6 according to the given problem it is phi 2. So we have started with phi 1 and we have ended up with phi 2. So this shows that f of x is an even function, and once the function is even, Bn will be equal to 0. So let us evaluate only a0 and an now. So a0, the expansion for a0 is this 2 by L integral 0 to L. I have already told you why is this 2, and f of x dx, and substituting for f of x in the interval 0 to L, that is 2 minus x into dx, 1 by 2, and this is the thing. Yeah, so half into 2x minus x square by 2 between the limit 0 and 4, and 1 by 2, and substituting the limits, upper limit minus the lower limit, we get this answer, and the value of a0 is 0. So 2 by L integral 0 to L f of x into cos n pi x by L, which is a formula for an. So an is missing here, you can write down an is, this is the formula, and 2 by x, 2 by 4, L is 4, integral 0 to 4, 2 minus x into cos n pi x by 4 into dx. So in the interval 0 to 4, so only one f of x is going to be considered, and n pi x by 4 into dx. Integrated, perform the integration by using Bernoulli's rule. First function, integration of the second function, minus differentiation of the first function and integration of the second function. Once we do, we get this step, and limits are between 0 and 4. Substitute the limits and simplify, we get the value of an is equal to minus 8 by n square pi square minus 1 to the power of n minus 1. So we had got a value for a0 and an. Bn is 0 because the function is even. So f of x is equal to a0 by 2. This is the main Fourier series expansion where we are going to substitute the value of a0 and an. Substitute it. And again this term, especially the term inside the bracket, minus 1 to the power of n and 1 minus 1. For different values of n, it becomes 0, and for some values of n, it gives minus 2. So when n is equal to odd values, this gives minus 2. When n takes the even value, this term becomes 0. So it's the summation n is equal to 1 to infinity can be written as summation 135 to infinity. Only the odd values, starts from 1 and goes up to infinity, and only the odd values are considered. So this gives us the minus 2 answer. Minus 2 and minus 8 is 16 by n square pi square, and cos n pi x by 4 is there as it is. So this is the Fourier series expansion. If it is only Fourier series expansion, we can stop it at this stage. But the answer which is asked is something else. So we have to go a step ahead in order to get the answer. So you have to substitute x is equal to 0 or x is equal to pi in order to get the required answer. So I'm leaving that to you. You can do it by yourself. There are some more problems I had listed out here for your reference. So try solving these problems so that you will get more confidence in solving the problems of 0 to 2L. So this is all about Fourier series expansion in the interval 0 to 2L. Thank you. For more queries, you can refer the notes. Thank you.